Hello there, guys and gals, and welcome to our real short here, Evolutionary Biology flowchart or concept map. So this picture here that we have in the background kind of describes to you everything that we've taken notes over and we've discussed and we've read about and we've watched and we learned about here in this unit. Did this to just try to show you how everything's kind of interconnected with this unit, how all the information, it does flow sequentially, okay, kind of like 1, 2, 3, 4, 5, 6, 7, 8, but 5 ties back into 2, 2 ties into 3 and 4, 4 goes back to 1. It's all interrelated, all right? And remember that we started off talking about evolutionary biology and how natural selection, okay, this guy right here in the center is a big deal here with this entire process, how it's the mechanism that drives evolution, that causes evolution. And we have this arrow going down from natural selection to the evolution box, all right? And the arrow describes the connection between the two, okay? So as we're looking at this concept map, items in the boxes are kind of rules, ideas, concepts, and the arrows connect the dots, okay? The arrows connect the boxes together, show the relationships, and usually have them accompanied with a description. Hence how natural selection, all right, not getting into definition of natural selection, but we know and we've covered how natural selection drives or is the mechanism for evolution. Hence the arrow going down evolution and description for that, okay? So with that solid footing, we'll go through a little bit of the rest of this thing, all right? And I'll allow you time to just kind of study and look over it yourself. We talk how evolution at the same point in time is driven by natural selection. So that's how we can go right back up to natural selection from evolution. So as you go from box to box, you can make it just kind of like a flow chart, but we want to show how it's related to one another, all right? So I went ahead and drew the arrow from evolution to natural selection so you could see that it's also connected. Like natural selection doesn't have to come before evolution, okay? In our description of evolutionary biology, we can say and start with evolution and say how natural selection is the mechanism that drives it, or it's driven by natural selection, okay? Moving on here, though, all right? Evolution is defined as change over time. And notice how many arrows we have leaving change over time and coming into change over time, all righty? So let's just go from change over time, and we'll go on the left side here, also seen as, because change over time, we talked about how that's also seen as just people or items or organisms adapting to their environment, okay? There are reasons to adapt to your environment or reasons that cause this change over time, and that's geography, geology, environmental conditions, food source, predators, and other major cataclysmic events that could change your landscape greatly, okay? And all of those reasons that you would need to adapt to your environment for, they cause species to, change over time. So we come right back to that idea and that concept again, okay? So natural selection, let's start back here at the center, is the mechanism for evolution, and evolution is defined as change over time, organisms changing over time. So you change over time because you have to adapt to your environment, and the reasons to adapt, we've got 5 of those listed here, there could be more, and adapting to those 5 items could cause a species to change over time. So see how it's cyclical. It all ties back in together. Now that change over time can create new species, and we call that speciation. And speciation in turn is driven by natural selection. Okay? So let's go ahead and define natural selection because we've seen it twice now tied in this concept map. Natural selection has 4 principles, and those 4 principles are variation amongst individuals in a population. Those variations are inherited, so passed from parent to offspring. A lot of naturally occurring populations overproduce their offspring so they can have a greater chance of the species surviving over time. And then the variations that provide a reproductive advantage, those are the variations that tend to get passed on from generation to generation. So 4 parts there. Now those 4 parts of the natural selection concept work together to fuel, I'm going down the right side here, work together to fuel survival, okay? The traits that are favorable are going to get passed on from parent to offspring because those traits are allowing the organisms to adapt to their environment and to survive in the ever-changing ecosystem and environment that they live in. So they work together to fuel survival of the species, which is in response to changes over time, changes to their environment, having to adapt to the environment, okay? So that's where we get this whole tie-in again with natural selection and how the 4 principles of natural selection blend right into this concept and this idea of items changing over time in response to a plethora of factors, okay? So getting back here to evolution, because evolution also is, new species being formed. Okay, that's what we talk about. So kind of coming back down through this trail that took us through change over time, through adapting, down through causing changes in species over time, to creating new species, which is evolution. All right, evolution is organisms changing over time, and it manifests itself in this creation of new species over the hundreds of thousands and millions of years. Okay, so evolution typically follows a few patterns, i.e. adaptive radiation, coevolution, convergent evolution, gradualism, and punctuated equilibrium. Those were items that we studied and took notes over in class, so I'm not going to go into great details with those right now. But evolution typically follows a few patterns, and those patterns are documented by evidence. We have evidence that supports the theory of evolution. Evidence which is the fossil record, anatomy and physiological studies, geography and geology, okay, of the fossil record, if you will, and of current organisms. Molecular biology and embryology, the two over the last 50, 60 years that have really taken off and supported the theory of evolution greatly. So all of these pieces of evidence, all of these support the theory of evolution. It brings us back together again to where we started, okay? One other, path I didn't take yet here was how natural selection happens as species adapt to their environment, and adapting to the environment is fueled by natural selection. Again, this whole idea of these four principles working together to fuel the survival of a species in response to changes over time. Okay, we're going to go through this in class. I just wanted to put this video up so you could watch it maybe once or twice and try to make a little sense of it. I know I went through it pretty quickly, but I didn't want to put a 50-minute video in front of you, okay? But this is a little walkthrough here for this evolutionary biology flowchart. If you study the two segments of notes that we took, you'll be able to understand this, and hopefully this helps you make more sense of everything, showing you the, again, interconnectedness and how all of it flows so very well together. If you got any questions, email me, contact me, give me a holler in class, seminar, before or after school, you can get a hold of me, okay? See you guys in class. Later.